Welcome to another episode of Complete Developer Podcast, the podcast by coders for coders about all aspects of creating your best life as a developer.
I'm Will, the accomplished developer and aspiring software architect.
And I'm Beej, the journeyman developer sharing my journey in development. It seems like most developers these days are pretty comfortable with relational databases. However, not everything can or should fit neatly into a relational model. For various reasons, a NoSql database that stores documents may be a much better solution. In this episode, we're going to discuss some of the things you need to consider when designing a document database and compare them to the things that you need to consider when creating a relational database model. But before we get started, Will, what have you been fighting this week?
Well, I've been fighting with my getting things done system.
Mm-hmm.
So, I got the book back in like 2007, 2008. And I mean, like there's certain books that you remember when you got them because it was an inflection point.
Yeah.
And that's one of mine, right? As far as like getting all my stuff organized, like having an understanding of what I've got to do on a certain day, having, notes in a reasonable place, prioritization of tasks. And it's worked for 12 years. The problem, though, is that a lot of the stuff I'm doing now, there's a lot of stuff that has dependencies on other things. And there's also a lot of situations I find myself in where I don't necessarily have a specific thing I need to do. I have a set of criteria. It's like, okay, I'm sitting in front of the computer. I have an hour and a $50 budget. What can I do that will move the needle right now?
Mm-hmm.
And my system falls down on that. And so I'm trying to figure out what I can do. And I don't think I can do it all in Nosby anymore, like I've been doing. So I'm just trying to come up with some kind of plan to fix that so that I can be a little bit more effective in the stuff I'm doing. So that's my major struggle right now. The other thing going on right now is I'm learning a lot on MongoDB, which is why this particular podcast entry came up, because I wanted to discuss how you might consider moving from the relational model to the document database model. And so there's going to be some things in here that probably people that are really good at document DB type stuff may not entirely agree with, but this is more of a transition from one to the other type episode versus these are perfectly best practices all the time. So I wanted to throw that in there. So how about you?
Well, that's actually really cool. When I read through the outline, I was wondering where your thought process was, because I know you've been looking into MongoDB. So
yeah, and I've done RavenDB before, and and I've done other stuff kind of along these same lines.
Yeah,
but yeah, it's definitely been some very interesting deep diving.
Yeah, I've looked into Raven and Mongo for a couple of projects where we thought document database would work better. And then I ended up getting put onto other projects. And so I didn't get to actually I got to do the research on it and go, hey, here's my suggestion. And then I got put on something else. Not that I'm complaining. I kind of enjoy that kind of work, but I didn't get to follow through. So I don't know what they went with. So last week, I talked about my trip to Alabama with Amanda to go see her brother get married. And during that, I talked about how we visited quite a few breweries. So per request, here is my review of the breweries we visited in Alabama. We went to Ghost Train, Trim Tab, Good People, and Avondale in Birmingham, and Serta when we were down in Mobile. All of that said, before I get into this, I will say I am currently drinking a Southern Pale Ale called Gravitational Nectar from Trim Tab, which is actually really good for an IPA kind of style beer. It's hoppy, but not too bitter. So getting into my review. Best beer, Good People, hands down. We actually bought Crowlers at Good People, and if you give me a second, I am looking. Amanda sent me the information because they're over at her place. It's Funk Farm Kettle Sour Cherry and Almond is the name of the beer we bought 2 Crowlers, and it's really good. I mean,
It's been a long time since I've had a sour.
this is one of the best sours I've had. It's great. We drank one of the Crowlers the other night while we were doing some artistic kind of creative stuff. I will say Trim Tab was definitely second. It was a close second, but good people. They've been at it longer, and they definitely had the better beer. Best place to buy a face mask was Trim Tab. Also, it was the only place we bought a face mask. So, yeah. Birmingham has a city ordinance where customers must wear a face mask when ordering at a bar or restaurant. So, we had to buy face masks, and Trim Tab had them on sale. So, we bought them there. Coolest seating goes to Ghost Train. They're over by the train yard, and they had stacked multiple box cars and made like cut out parts of the boxcar to make covered outdoor seating. It was really cool. And honestly, guys, I'll have to post some pictures. I did on my personal Insta. I'll throw them up on the podcast Instagram because they're really cool. Best music venue was definitely Avondale. They had a huge stage. Though Ghost Train had a pretty cool outdoor stage too. I'd probably enjoy seeing a concert there as well. Most relaxing venue was definitely Serta. You guys remember I said last week how Saturday night I was just like, wow, I'm actually relaxed. That's where I was when I said it. They have a bar around their brewing vats, which is really cool. But the best was the outdoor seating. It was just so relaxing and laid back and just a lot of fun. In other news, I have found that I get more done if I start my workday an hour later in the mornings. I realize that sounds kind of weird. The last, several weeks before I went on vacation even, I've been trying to get up earlier in the day to get some stuff done in the morning before I start my workday. And I was struggling. Honestly, I was straight up failing at it because I would set an alarm an hour earlier than I normally get up, and I would just, either hit the snooze button or turn it off and then get up at my normal time anyway. So I thought, well, what happens if I push my start time at work back? Because I pushed it up to an hour earlier than normal about a year or two ago so that I could get stuff done at work before everybody came in. Now it doesn't matter because people come in early. They learned that. And so now they just literally I start my day at 7:30 and I have gotten calls at 7:35 from coworkers. And it's like, well, there's no point in starting that early. So I just said, hey, what if I push it back by an hour, start at 8:30 like I used to, and spend that time doing what I wanted to do in the mornings. Done it 2 days this week, and already I can just tell, yesterday, even Amanda, we went to the gym last night and she was like, you are way more relaxed than you normally are on a Monday. And I'm like, yeah, well, this is why. And she's like, oh, that was smart.
Yeah, sometimes it doesn't take a whole lot of adjustment, and huge win.
Well, I had been trying for at least a month, maybe 2, to get stuff done in the morning before I started my workday, and I couldn't get myself up early enough. Pushing my workday back, I have to instead of getting off at 3:30 or 4, it's now 4:30 or 5. Still doing that, not a big deal. I'm still able to get everything I want done in the evening because I'm better at getting stuff done in the evening than the morning. It's funny how that adjustment is what worked. Also, small group semester has ended at church. So I got a bit more free time now. Will and I were just talking about that. Using it to actually stay relaxed, doing artistic stuff and things like that. On a similar note, I have an announcement for you all after book club. So let's go ahead and get on into it. The final quality of a team player is tenacious. A quote from the book, never, never, never quit. Maxwell starts his last chapter with a personal story about a trip to London with his wife and some friends. While he wanted to see the home of John Wesley and another of his friends wanted to visit sites related to C.S. Lewis, one of his friends had his heart set on getting a picture at Abbey Road like the Beatles album. Now, if you guys are wondering, yes, I've been to Abbey Road. Yes, I did get a picture. Yes, I was barefoot. Unfortunately, when they went to get the picture, the road was closed for construction. Being that this was their last day in London, it was their only chance to get the picture. So they persisted in talking with the construction crew until eventually the crew allowed them to take the picture. Maxwell goes on to talk about how tenacity is crucial to success, giving 3 ways tenacity is expressed. First, it means giving all that you have, but that doesn't mean giving more than you have to give. Next, it is working with determination instead of relying on luck or fate. Finally, tenacity is not quitting until the job is done, no matter how tired you become along the way. He closes with 3 ways to improve your own tenacity. Work hard and smart. Stand for something and act with integrity toward it. And make work into a competitive game. So, guys, this is our last week talking about the 17 qualities of a team player, which you'll have a link to in the show notes. I'm going to take a bit of a midsummer break from book club for a couple of months. Because we record a month in advance, it's going to be more like a late summer, early fall break to you guys. But for me, it'll be midsummer. However, I'll pick it back up in a few months. And if you have a suggestion or a request when we start this back, send it to neckbeards@completedeveloperpodcast.com.
Your advertisement could be here. Well, if you like the show, that is, and you'd like to advertise on here, you could send us an email to adverts@completedeveloperpodcast.com. We have short-term, long-term, and other sponsorship opportunities. We'd love to hear from you. Reach out to us and let us help you reach the people that you are serving.
Document databases are becoming increasingly common. Not only do they offer a lot of advantages over relational databases in certain contexts, but they also greatly reduce the friction of working with data when using object-oriented languages. These advantages often make it easier to work with your data. They can also make it easier to rapidly iterate on your design as you develop your software.
However, much like agile principles, all of this flexibility can really get you into trouble if you're not disciplined. Simply being able to do more things doesn't make all those things prudent, scalable, or sustainable.
The structure of your data matters. This is still true when you're using NoSql data models. However, while many developers know how to build decent relational databases, a lot of us are at a loss the first time we encounter a database with a non-relational structure.
In this episode, we talk about how some of your design considerations will change when using a document DB. We'll first discuss the design concerns that are common for relational databases, and then we'll contrast those with document databases. Next, we'll talk about how common relational models can be expressed in document databases. So let's open up with, kind of a discussion of the major concerns for a relational database. Basically, what are they optimizing for? What are they not worried about? And then we'll talk about how that's different than document databases, because this is kind of the crux of the problem. The first major concern for a relational database is duplication of data. You do not want that in a relational model in general.
Yeah, I know. I'm not currently working on it, but the application I worked on for about a year and a half, almost 2 years, had an issue with some duplication, and turned out to be an issue with the way that the ORM was handling a join table, where the ORM software, it was, instead of updating a row whenever it would get an update, it would delete the row and create a new one in the join table.
Yeah.
Sometimes it would not delete before adding the new one. And so you would get like duplications in the join table only. Really weird error. And so we're like, I'm working with another developer. He's actually working on it, and I'm almost overseeing it. It's weird because I'm not in a management or lead position, and he's been developing longer than you have. So like he was probably a senior developer when we were in high school, you know? So it's interesting, but like that duplication of data is a big issue.
I think people forget that the relational database thing came out of a different time,
Mm-hmm.
right? Like it's a time when memory was very expensive, when disk IO was very, very slow compared to what it is today. And a lot of systems, I think back then, probably wrote data a lot more often comparatively to how often they read it. You know, because now you get all these charts and graphs and reports. You know, like if you look at, systems back in the day, sometimes people would have to actually write programs to sift through the data and get a result out. So like you had to actually talk to a programmer to get a report built versus, okay, I'm going to write a SQL query to do it. Like some dude had to implement that and run through the system. And as a result of that, they tend to want to have a single store of truth. They tend to want to limit the amount of stuff that is changed when an update occurs. So it only changes, like the parent table or the child table, not both, not willy nilly. And those considerations, while useful in some contexts, are not necessarily things that always serve us now. So what you tended to have in this situation is you had the flat structures that were connected by joins. And that's how you said, hey, here's, two different things that vary somewhat independently of each other. And that's how you separated that. You might even put it on separate volumes, disk volumes. You still do that with relational databases if you get at scale. The focus in the design tended to be on the entities and their relationships to each other,
Mm-hmm.
at the database level. And back in the day, I mean, when I was learning to program and I was, learning how to build stuff in like VB Classic, they're like, you design your database and then you design your stored procedures that are calling those tables and returning the data shaped like you want it. And then you write your program on top of that. Right. And now that has completely flipped on its head. You write your code and you figure out what shape the data needs to be. And then you create the data model down instead of database up. And as a result of this focus on the entities and their relationships, you had a different way of interacting with the data. And so if you've learned the relational model, there's stuff in the document database type model that is still kind of the same, but there's a lot of stuff where your assumptions are turned on their head. And so you've just got to kind of prepare for that.
Yeah. So, question based on what you said, if you have a one-to-many relationship, would you use a join table for that?
In a document database?
No, in a relational database.
A one-to-many? I wouldn't have a join table in there.
Yeah, that's
typically. But the problem is, and you learn this doing databases for long enough, is that a lot of times people say something is one-to-many, and then over time, their definition adapts to become many-to-many.
Mm-hmm.
And it's the same thing with your join tables, right? You're like, oh, this is a join table, but we need to add this other little bit of data. And then you get another little bit of data. And pretty soon, this is actually an intermediary table between the two things. It's an entity of its own.
Yeah.
So there's also a lot of considerations that happen there.
I'm very strict about that. And so are the DBAs I work with. They will not let join tables become intermediary tables. They're like, oh, do we need an intermediary table? We'll make one, but we're not going to turn a join into that.
That must be nice.
Yeah, I actually work with some really good people. No, the reason I asked that is because of my knowledge, or my lack of knowledge, I should say, of Hibernate. When I first started the project, we made the decision to make one-to-many relationships use join tables because that's the only thing I knew how to use at the time. Mind you, like I said, this was several years ago when I first started. Like this was the first project I worked on at my job. And I wasn't the one who made that call because I was a junior developer at the time. I just followed the lead on that. Yeah, and then we had that issue I was telling you about. So we had to go in and go, all right, all these are actually one to many and not many to many. So we could completely get rid of these join tables. There's no need to have them at all. And so that's what this other developer's been doing, and I've been helping him out. It's been weird because I've been sort of like oversight and helping him understand some of the weird business rules, but yeah.
Yeah, I mean, you do tend to get stuck on the entity definitions, and the fact is those change over time a lot. Yeah, so that's one of the weaknesses I think of the relational model. The other thing is our code model is not built around this anymore, right? Like back in the day, it was like, yeah, you get a set of records, you loop over them, you call subroutines on the next thing. You know, it wasn't so object oriented, and it wasn't like, you know, it didn't have all the stuff in the mix like middleware and all this other things that, you know, that we're so used to now.
Yeah.
Yeah. So it's a big difference. I mean, the other thing too is on a relational database, you tend to build the data model. And then when you're like, okay, I've now got to talk to this construction I've made that is designed to store my data, how am I going to do it? And then you start building up queries and you start building up indices and those kind of things to make those things happen. So your business rules are almost encoded in your data structure versus being in your app. Even though the app may have a lot of business rules in it, like you have a violation of separation of concerns there that naturally occurs with a relational model.
So now with all that, we're going to talk about how the document databases do it. First off, data structure is highly based around how it will be retrieved and structured based on how it will be read.
Yeah. So in document databases, there is a little bit of support for relationships between documents, but that, you know, it's not that it's not a first class entity. It's just that it's not as important in the design. You know, it's not front and center. Here's how you do it. You know, because you talk about relational databases, like literally it's in the name. It's relational. Yeah. It's not that important here, you know, comparatively. It still matters, but it's not a core thing. The data that is generally read together is generally stored together.
Yeah, right? It's like one document, like one set of data.
It's like a document in a file cabinet.
Yeah.
You know, like, so you don't want to look through your filing cabinet and go, oh, here's my record for BJ Burns. Okay. His home address is retrievable at GUID, whatever. Let me find the file with that GUID. Go through the filing cabinet. Oh, wait, you know, it's here's his phone number. Well, but what country is it? Here's a GUID for the country. I'll look that up. Right? Like you would never do this in a normal paper filing system.
Yeah.
But you straight up do this all the time in a relational database.
Yeah. And it goes back to, like you were saying, the way that like you had to store information before because of the constraints when relational databases came about. Like the whole point of relational databases was because of the constraints. Like document DBs they're not new. They've been around for a long time. It's just they weren't practical.
Right. And, you know, largely, you know, especially in larger organizations that actually needed a database, like it was cost prohibitive to store that much data. Like if you duplicated data, that was a waste of money. It still is, by the way. It's just that it's so much less of a waste of money now than it used to be that we don't care because programmer time is cheap or is expensive comparatively. And disk space is cheap and memory is cheap. But I mean, back in the day, like if you look at what 4 megs of RAM used to cost, 4 megs, not gigs, it was absolutely insane. Like look at what it cost in like 1992 to have 4 megs of RAM, and realize that these concepts go back to the 70s. So yeah, it was a big deal.
The whole point was to break it down into easier to process chunks.
Right, because you couldn't load that much into memory.
Yeah.
And so you had to worry about paging. You had to, and you still actually do if you go a low enough level. It's just most of us don't. And you had to think about, how much space do I have on the heap? Do I want a
Yeah.
table that exceeds that space? Like those considerations were front and center. And that's not the case now. So duplicate data is generally less of a concern than it would be in a relational model. That doesn't make it not a concern because you still want to have one source of truth and other things update, and you need to figure that stuff out. But it's now not the tyranny of high cost that's driving you to that decision.
So the first thing we're really going to talk about is one-to-one relationships. In a relational database, you might model such a relationship in a single table or in two tables with a relationship between them. Like what I was talking about before with the one-to-many, one-to-one, that was something I knew how to do when building this. So we have several one-to-one relationships there in the database, the relational database I was talking about, where it's, and we have one that's really, really confusing because if it weren't for certain business rules, it would all be flat on one table because it should be. But because of certain business rules, some parts are like interchangeable. So they have to be on a one-to-one relationship with that. It's weird.
Yeah. I mean, like the thing with one-to-one relationships is it's actually a pathological case of one-to-many.
Mm-hmm.
And you're living in an exception that you don't think about.
Wow, I hadn't thought about it that way.
Yeah.
Literally. But that makes sense. I follow what you're saying. I just hadn't thought about it that way.
Yeah. Well, I remember dealing with a database design that evolved, and that hit me in the face one day. And I was like, man, that's really deep. But it's really not. It's just, again, you don't think about this kind of stuff.
No, you don't.
But in a document database, what you would do with a one-to-one is you put it all in a single document with nullable fields as required.
Yeah.
And you're done.
Mm-hmm.
You could also say, hey, it's, I think there might be an option for this to be many to many. You still put it in one document. The nice thing about this is it's a real simple case and it gets rid of a join. So you're not having to do a join. You just go, hey, I want the document with this ID. Give me the document. And all the stuff comes with it.
That's one of the big benefits of the document databases. You don't have to have these complex queries that go, all right, give me this. Oh, hey, to get the other information associated with this, it's got an ID on it that I have to then go say, hey, give me this from this table and this from this table and this from this table and put them in the right places. No, it's all there.
Yeah. And the thing about it too is that you can also filter the stuff that you get once you get the whole document back. You filter it in memory instead of doing it in SQL. In some of those cases, right? Like, so if you've got a bunch of child records and you go, hey, I want just the active organizations under this, product category. Well, you might just go, I'll pull the product category back and I just filter those in memory if it's small enough. Because you may not care, but if you're in a relational model, you're going to have to join out and get those things anyway. And so you care at a different place in your app. Sometimes that's advantageous. Sometimes it's not.
Yeah, it kind of depends on where you want to put the workload.
Yeah.
Where do you want that load for your standard application with a front end, middle, like business layer, and then back end database layer? In a relational model, historically, you would want that work done at the database layer because that's where you're going to have the most power, the most ability to do that. But with the document database, with the current the way we have things now, that could be moved almost even all the way up to the browser.
It could. People do that. I've seen people do this where they'll directly call a MongoDB instance out on the cloud somewhere from their front end code. And it's like, look, this user has these permissions and, this level of access. And so there's only certain things they can get to and they can grab this stuff. It tends to be like, publicly available data stores. But the nice thing is okay, it's cheap for the database to just get the information and just chuck that over the wire. And the client deals with all the processing, especially if it's heavy processing. You don't want to put that on the database server. Database CPU cycles are your most expensive CPU cycles that you have. So move it off of that.
I was talking with our UI lead. We're working on, it's sort of a side project turn major project for reading our logs and then also logging from the UI. And and I should actually talk to him about using a document DB for this instead of what we're doing. But because that would work even better. Side note for myself. Anyway, what I'm getting at is like we actually had this discussion of, hey, where do we want to process this? And he was like, well, it's probably going to cost more to make multiple calls across the wire than it is to send it all and have the browser process it, because the browsers can handle that much processing now.
Yeah. The other thing with these kind of databases with web apps is they tend to work a little bit better with the whole RESTful type worldview.
Mm-hmm.
Because if you think about like updates in regular SQL are more of a patch than they are a put.
Yeah.
In a lot of cases. And so with a document database, it may be advantageous. Not necessarily always, but sometimes that shift is actually quite valuable. Back to the one-to-one relationships, if you have to update either record, you just update that document. You pulled it back, you make the changes, you put it back in.
Yeah.
Now, you can do mutations and those kind of things, especially if you start getting into all the GraphQL stuff. But realistically, you're updating that document, right? You're not joining out to some other table and then updating where some condition is matched and possibly screwing up data from other documents. It's just, here's the chunk of stuff.
Mm-hmm.
And so sometimes that layer of abstraction makes it easier for developers not to screw up, which is why we like this kind of stuff.
Yeah, exactly.
So the next step up is, your one-to-many relationships. And I broke these up because there's a one to not too many, and then there's a one to very many. Right? Because think about it like this. You have a circle of friends, right? Let's say you have 10 friends. Okay. Having 10 friends and graphing those relationships and knowing that, that's not a big deal. If you've got 1 million fans, that's a different database structure. In relational, we tend to treat that as the same because we're just like, oh, just put those relationships off in another table. But we still typically are not going to bring back the head and all the stuff under it for those big ones, because that's crazy. Even though developers do this all the time, it's really not a good idea. So if you've got a one to not terribly many in a relational database, you typically have a parent table with a child table that has a foreign key back to the parent.
Mm-hmm.
Sometimes you'll do like the variant that you have, like if you think it might go from one to many to many to many, and you have an intermediary table in there, just to go, okay, well, this is a problem I'm not going to have later at the expense of more joins. Sometimes that happens, which is fine. In a relational model, you'll retrieve the parent and children in one shot, typically either by using a join between the two or two result sets coming back in the same query.
Yeah.
One for the parent and then one for the child, and then you correlate it in your code and try to like reassemble the objects, because that never goes wrong. Everybody does that perfect the first time.
Well, so it's really funny because I've looked at the SQL output for some of the different ORMs when we were looking at various ones, and it's
how much
really
profanity
weird.
Did you use?
More than I care to admit. Yeah, because like I'm like, why? And it's like, it's almost like the developers didn't understand how to use a join, because they were doing like, they're just bringing it back and then trying to relate it. And I'm like, you could have used a join there and that would have just like helped a lot. You know that, right?
Well, you can either do it as a flat data set that has all the things in it, or two data sets, and then you have a correlation ID between the two.
Mm-hmm. That's what they were doing. They're like doing, and it wasn't just two.
Yeah,
because it was a complex.
Well, I can tell you why that happens, because what joins do, right? They combine the fields of both tables. If you have 5 tables in the mix, you have a combinatorial explosion. And so you're pushing stuff over the wire that is duplicate data.
Okay, I see what you're saying.
Duplicate data going over a wire is expensive. So you break it into data sets. Like if you're writing an ORM, you don't know what kind of crap people are going to do to it, but you got a pretty good idea because people are crazy. And so that's what they end up doing. So the document database gets around this, because if the children are not relevant without the parents, then the children exist in the parents. Essentially, if they're not an entity that stands on their own, then they ship with the thing that owns them. So like order, information and order details would go together, right? Because an order detail line in the context of an ordering system isn't separate from an order. Now, in the context of an inventory system, it very much is. But just within that particular domain model, it's not. And so you ship them together.
Mm-hmm. Like a transaction versus a line item on that transaction.
Yeah. Although you notice I dodged the use of the word transaction because we're talking databases.
I know.
Yeah. But yeah, that's essentially the idea there.
It's a tricky word, but yeah. Yeah. Now, in a document database, if the children are not relevant without the parent, you'd simply have an array in the document being stored.
Right. And retrieval of this data set doesn't require a join, and it doesn't require any special parsing logic to break up that result set. It's like, here is a JSON document or possibly an XML document, or if you're a sadist, maybe YAML or something else. Who knows? I don't know anybody that would want to do that, but somebody's probably going to try it now that they heard me talk about it being sadistic, because there's always that one dude.
Or a woman. It could be a woman. I know some women who would do that. So yeah.
Yeah. This is true. I know plenty of people that would try something crazy. I usually refer to such a person as a dude, but sometimes they're a female dude.
Yeah,
I'm using dude in the California dialect of dude, not.
Oh yeah, the gender neutral term of dude.
Yeah, right. So
okay,
they're just
fair enough.
They're a dude. That's a placeholder for a person. It's an object of type person, and I don't care what interfaces they're implementing.
Wow.
So
wow, I like that. That's good. That's impressive.
Yeah. Retrieval of the data set doesn't require join, like we discussed. It doesn't require parsing. So you get the whole thing in one shot. But the downside of this is when you update a child record, you're updating the parent, right? So you pull the parent back, you update the child, and you push the whole thing back.
Mm-hmm.
In a lot of these cases. Now there's ways to do this where you don't, where you're just updating the one part. But something along those lines is probably what's going to happen.
Yeah, I've run into some issues working with various ORMs where you kind of have to do that too, where if you don't set it up right from the very, very outset, you end up having to update the entire thing to update a grandchild even.
Yeah, and
that's a pain.
Relational database models are really bad for this, about forcing you to plan up front. And it's like, dude, we do agile badly. That's not what happens. Like that's not the way the industry.
Dude, even if you do agile perfectly,
yeah, the things change.
It still costs a lot to make those changes with a relational database. You have to, you almost have to do agile slightly poorly to functionally use a relational database.
Right.
In some cases.
Whereas with a document database, you can get away with more.
That's very true. Yeah. No. So moving on to the one to a great many relationships, as Will wrote in his outline.
Right. So let's say that, again, one to many relationships is, I'm one person, I have many friends. You don't do this and say, hey, this is Taylor Swift's record and here's her fans. Because when you pull back Taylor Swift, you're going to get all of those.
Mm-hmm.
And that's probably not a real good situation for, timeouts in HTTP, for one thing. So when you have a whole lot of relationships, in a relational database, you would express this as two tables joined with a foreign key. Hopefully you index the ever-loving crap out of it if you've got a lot of records, because you're going to probably want that. In a document database, this typically would not all be stored under the parent. So in this case, instead of a parent bringing back all the child records will have a reference to the parent, and they'll be off separate.
That's kind of similar to the way that relational databases do it, where the child references the parent.
It is, but I will tell you, for instance, if you're using Entity Framework, just to pick on something that I like to bully all the time anyway. Let's say that you have the parent and child. In Entity Framework, if you say, I want to deep load the children under this parent, I can't page that result set with a ORM type mapping, right? It's like you get them all versus I want the first 50 of them, and then I want to be able to make a call to get the second 50. So It's not so much the database technology changes, but the stuff we've layered on top of it changes. And I think in Hibernate, it may be a similar thing too, right? And the deal is they're tracking changes. And so they don't want you pulling 50 in, making some changes, and then they when you save it, it goes, oh, these other records aren't here, delete them.
Yeah,
So
yeah.
there's an ORM logic thing in the mix there that isn't here because you don't need an object relational mapper, and so you don't have that layer.
Yeah, so with the ORM, what you have to do is you have to write custom code for that. The ORM itself won't do it.
Right.
What you have to do is write a custom query. I took some stuff that you taught me. I kind of applied it in a unique way. So you taught me about creating like a generic, using generics to create a basic generic get post kind of stuff and get by ID. I took it a step further and I created a generic where I can create a where clause.
Yeah.
Actually, I have to create in C#. It has to be an expression of a function.
Right.
I pass that in to a generic. And so I can just have a generic where, or I can have a generic like get single based on a where clause. And so I can create that, like I can map that out for any mapping that I have in my code, like in my ORM. But it's something that like that I can do that with an ORM, but I have to do custom code for it. I have to go, all right,
every time that you want to page it too, separately. Yeah.
Yeah. So I have a pagination basically snippet that I use for that, where I say, all right, here's the where clause, bring back, and within the where clause, you can paginate within the where clause. And that's how I have to do it there for a relational database.
Yeah. I need to show you the query builder pattern.
All right. Yeah.
Yeah. Cause it's way less.
Well, this isn't painful at all. Once
it still sucks.
I built this snippet, I just use that snippet and then apply it where I need to. But it's a code snippet. I've got a bunch of code snippets that I reuse throughout because and if I can make them generic, I will. But a lot of times with this kind of stuff, you can't.
Yeah. So anyway, with the document database, right, you break the child records off into their own documents. Because you think about it, if there's one thing and it's got a million records under it, that's not really one thing. That's a million one things, right? Like, why are you storing this many things if they're not relevant? So those are probably separate documents anyway. And so that's what you typically do. And you do a reference back to the parent so that you can grab a same size chunk of records, as you need them that match the parent. So you just have to have some way of sorting them. And you say, okay, give me the first 50. Boom. There's 50 of them.
Mm-hmm.
Now this can be done. Some really interesting things can be done with this as a system scales that you can't do as easily in a relational model. So you can also do a hybrid approach. So your parent document could say, okay, I'm going to have up to 50 items in an array under the parent. And I'm going to have a bit field to say, hey, there's more than 50. And the system can know to go out and get them somewhere else. Twitter uses something like this for their larger accounts. So like if you have an account that's got 1 million followers, some of the code actually changes between, what Twitter does with that versus what it would do with like me or you, because like our list of followers could be stored in a document, but I don't know, the president's list of followers probably couldn't be, right? Anybody whose name you would actually know outside of a programming circle is going to get that hybrid document. And so this lets you make changes as you scale in a way that means that you don't mess with most of your data, but you just deal with the pathological cases in a, switch type manner. Mm-hmm. And so you can get away with this in a document database, whereas in a relational, it's like, nope, it's all in this table.
I follow you. That makes sense. So the next topic we're going to talk about, since we've talked about one-to-one and one-to-many, it's time to jump all the way up to many-to-many relationships. Now, in a relational database model, this would be expressed by having two entity tables with a join table between them. This is what I was talking about earlier, how we treated a one-to-many relationship as if it were many-to-many. And then you would have a lot of joins used for the retrieval of this. So, I mean, it's basically with this, you have two tables for, like, you have a parent table and then a child table with all the child records. And then you have a join with foreign keys for each one. And so when you call it, or when you're ORM, because if you're doing relational databases, you're probably using an ORM if you're sane. Otherwise, it's a pain in the you know what.
Yeah.
So what you're doing is what it's doing is going, hey, give me pull back all the foreign keys that like all the child foreign keys that are associated with this parent foreign key from the join, and then it's going to that child table and going, hey, pull back all the records with this ID.
Yeah, and many to many gets interesting when you try to move that to a document database because the model isn't really based around entities as much.
Mm-hmm.
It's instead based around how they're read. Typically, if you have a many to many, one side is more important than the other. I'll give you an example. A blog engine software. Posts are the thing most people care about. Tags are not so much. Yeah, they're used in searching and stuff, but realistically, people, are going to be reading the post, not going to the tag page all the time. And so one side of that is more important than the other. And so you don't have a one size fits all data store here anymore. So it's entirely possible that you might express a relationship with two separate documents, one for each end of the relationship that have a list of items under them. So like an array, the post has array of tags. The tag document has a list of posts under it. And you just keep both those two things in sync. You're probably not going to have an intermediary join document. That's weird. It's not a thing that people are generally going to do unless that becomes its own document at some point in the future.
It'd be really interesting trying to keep both of these up to date because when you update one, you have to update the other.
Right. So you end up with a whole, message stream type situation.
Mm-hmm. So what happens if you've got a document database and you're able to update one side and then you have some kind of error or some type of internet outage or something updating the other side? I don't know. Something that blocks the update on the other side. Like, how do you reconcile that?
You can, in some of these systems, actually do transactions still. I don't think all of them do that. And I'm not sure if Mongo does or not because I haven't run into this. The other thing is one of your most common things that happens in a database system that stops something from being written, other than just a complete screw up or a network outage, is a situation where you have a deadlock or something like that. And you just don't get those as much here, right? Because you're reading a document, writing a document. It's not some join table that everything is touching all the time.
Yeah, that makes sense. So next we're going to talk about hierarchies. In relational databases, this will either be modeled using some sort of hierarchy ID type and the related functions, or simply be a long chain of foreign keys. That's a pain.
Yeah, I've been there, done that. You get deep hierarchies and you have dozens of joins. Or what you typically do is you read something and you go, oh, what's the parent? You get the parent. Oh, what's the parent? And you keep going until you get a null. And so you get all this network traffic from it. Or you read the whole thing into memory and then shuffle it client side in some other language, like you did in C# so that you don't have to try to do that in a database.
Yeah.
Which is what I tend to do if it's a small hierarchy.
That's what I usually do. I've got dealing with this. Oh my goodness. Like it's been probably about a year or so since I've worked on this project I'm helping the other developer fix. And like he'll ask a question. I'm like, yeah, give me a moment and I'll go like have to read through the code to figure out what I did. Cause it's been a while, man. Like I didn't think that when I was writing it. And I'm like, wow, that's actually changed. Helping him fix this has actually changed the way I write code to be more legible. And I'm putting more comments in there to help me figure out what I'm thinking.
Yeah, and you don't do things clever anymore either, probably.
Oh, no, I'm still clever.
You don't try to be like clever where you're like, that was smart. You're like, that was eloquent. Those are two very different things.
True that, yo.
So in a document database, you typically, you got a lot of options depending on how much data you're actually storing. For instance, if the hierarchy doesn't change frequently and it's small, you just stuff that thing in a whole document. JSON, it'll take a lot of nesting before you have a problem.
Mm-hmm.
You might also say, hey, each node is its own document. And then in each node, you have a array with references back to the parents all the way back to the beginning, and references, like an array with references to all the children. Now, that means when you change the hierarchy, you have to update a lot of things, but more than likely, that's not happening very much compared to, because like if somebody sets up a menu structure on their website, something that's hierarchical type setup, they're not changing that thing every day. And even if they are changing it
Mm-hmm.
every day, if they're having to do that, the website's probably being accessed 100,000 times for every time that thing changes. So you can
Yeah.
take the hit on that if it's big enough. Now, most of the time, you're just going to be like, hey, stuff this thing in a document. I don't really care, because really what you're doing here is you're saying, I don't want to put this on the file system. Treat the document database as a file system.
Yeah, I'm just thinking about the hierarchy with that, like with that particular one, because we ran into some issues where this was one of those points where the business people knew part of the business but not all of the business.
Yep.
And so like we built for what we thought we were supposed to build for, and it turned out what we were building thinking was their primary business was actually only about 10% of their primary business.
Yeah.
And so we had to make changes quickly towards the end. And I'm sitting here thinking, I'm like, wow, like we made a lot of those hierarchical changes, but it was a pain with a relational database.
Yeah. I mean, the other thing with the document database is your hierarchy. Now, this is something I probably should have touched on a little bit more. Sometimes you don't necessarily use a document database as your only database.
Mm-hmm.
It might be your front facing database, and your back end might still be relational. And so some of
Yeah, I could see
these,
that.
and it could be the source of truth. And you go, hey, we're just going to update this thing every day, and we're just going to pull it over, build a document, and cram it in the document database. And it's a cache at that point.
Yeah, that's basically. Remember when I was saying I had done some research on various document DBs to figure out which one to use? That's what the project was doing. Like the main store was in a relational database, and the quick access, easily searchable was in a document database.
Yep. We do this with Elasticsearch at work for the same
Yeah,
thing.
that's exactly what we were aiming for, was Elasticsearch. Unfortunately, I didn't actually get to build it. I'm kind of sad because it was really cool.
You're not that
But
sad. I deal with Elasticsearch and stuff like the aliases getting messed up, and instead of, and it using aliases instead of indices, and your query performance going down the toilet, and the tooling isn't like I would like
yeah,
for troubleshooting that. So you might have dodged a bullet there, friend.
I very well may have, because I'm getting to do some really cool stuff. Like right after this, they pulled me off to put me on something that was literally using technology that came out the month before I was asked to build it. Like some .NET Core stuff that came out the month before they asked me to build it, and like, hey, we found out about this new stuff in .NET Core, so build this.
Yeah. Now I will say that with hierarchies, stored in a document database, the downside is that a lot of these approaches are going to require you to do a lot of writes to make
Mm-hmm.
a change, because it's a tree. And so, yeah, you're kind of stuck with that. Honestly, if you're doing this in SQL or something else, you're probably going to be doing some of that kind of stuff anyway. And you're going to be writing more than you think.
Mm-hmm.
But that's just something to kind of keep in mind. But reads are the bulk of data access, and this is a single operation instead of a bunch of expensive operations. So it's still a much better approach.
Yeah. So the next thing we're going to talk about is key value pairs. In a relational database, this is often done with a 3-column table, with one column for the related entity, one column for the key, and another column for the value.
Yeah. And type safety at that point is complete and utter garbage. And index performance is also going to be garbage or slightly worse.
Mm-hmm.
In a document database, you store this crap in a dictionary under the entity document. provided that it's small in size, and you go on with life. If it's a larger amount of data or if some parts aren't frequently used, you can break it up and you can store chunks in different documents in different places. You get better type safety too.
Also, helping to avoid type safety and performance issues of the relational model, it's easier to store complex types in the structure without having to serialize JSON or do like weird things with your key to indicate nesting.
Yeah. Can you tell I've done that a few times?
Yeah.
Yeah. I like try not to do that in a relational database. I mean, like sometimes you can't help it, but you're pretty much always going to regret it.
Mhm.
So, yeah. So now the next one that comes up not overly often, but it comes up some in relational databases is what is called a sparse table. So sometimes your entity will have a crap ton of fields on it, but most of them are null most of the time. That's
Mhm.
why they call it a sparse table.
Yeah.
And there's a lot of reasons for this. Sometimes stuff gets added and you've got historical records that used to have this thing and it's on here, but now it's not required. So we leave those null and yada, yada.
Or vice versa, where the historic records don't have the new stuff because they're like, hey, we want to take this in, but we haven't before. So the new stuff is, but the stuff we're bringing in from the old database doesn't. That's what I've run into a
Yeah.
lot. In a relational model, you can do a lot of different things for this. Uh, Key value pairs, nullable columns, or even multiple other tables for sets of values can be used. Each of these approaches has its own problems. You kind of just pick the problem set that you can live with.
Yeah. And a document database, these are nullable fields on the document and you go on with life because they aren't serialized if they aren't there.
Yeah. Which makes it a lot easier because, I mean, oh man, I remember when we started migrating data over on that project I was talking about, and the DBA, I mean, I feel for her because she was preparing for knee surgery at the time and trying to deal with this. Plus, we had a manager whose attitude was, I don't want you to know anything about the old system because I want you to build the new system like
Not
completely
the
the way
same
it should.
way.
Not the same way,
I want you to
but
make new mistakes.
yeah. Well, because we didn't know the old system, we didn't know, like we weren't able to easily translate. Like it became a whole big issue that had we known, had we been allowed to go, oh, that's how it's stored there. We're going to store it differently, but where it can relate. It's just, it was like, it was a holdover from having worked with previous developers who were lazy and would go, oh, the old system's that
And
way.
would have copied and pasted it.
Yeah. Yeah. And it's like, we're not like that. Both of us who are developers on this project, we're not like this, but no, it's still just like this holdover from that. So
Yeah. And I got a few final thoughts, so we can roll this thing up. These are some things I've observed as I've been kind of getting better at this. Storing things in a document database is eerily similar to the way a lot of really old apps stored things in the file system. It's got a lot of the same kind of structural problems or structural patterns. So it's like, hey, you store the data that goes together, you put it in the same place because you're reading it together. Well, you do that with a file system too. You have a unique identifier for each record. Maybe in some cases, when you need to index, you have an index off to the side in another file. It's similar in a lot of ways.
So, you saying that makes me think of, I learned about document databases and then I had to write a service that worked with file systems. And like thinking back on it, I'm like, oh, yeah, I understood that better because I knew about document databases. So
Yeah, I mean,
from the opposite perspective, from like a newer developer flipping it over, it makes sense.
well, the only thing different with the file system is your querying and concurrency is not as good,
Mm-hmm.
right? Because you lock a whole file
Yeah.
potentially while you're working with it.
Oh, that's a pain in the butt too, by the way.
In a lot of cases, but again, there's different like random access type stuff. But now another thing too is your document database does not have to be your entire data storage. It frees you up. Don't take it to the places where it doesn't. It can be really effective even if you just use it to cache the results of complex queries from the back end of the system. If it takes the load off the system, that's a win. And you can do this stuff gradually. I'll also say that while concurrency problems are often alleviated by document databases, but there's cases where they're not. And so you might need some other infrastructure in there, like event streaming, where it's like, okay, here's a list of things that have happened to mutate state, and I can put these in order. I might be able to, split the load out to multiple databases. So I have the same document in 2 different places, and I have the event stream, and I can mutate both of them independently of each other. And that's how I load balance.
Mm-hmm.
That's a reasonable way to go about that. I think that's probably easier with document DBs than it is with relational.
That makes sense. So guys, document databases are becoming increasingly common and important parts of modern software architecture. While there are a few spots where they are tricky to use, they can often supplement or even replace older relational models. If nothing else, the simplicity of working with them and the avoidance of object relational impedance mismatch is often worth the trouble. That pretty much wraps us up before we close everything out. Will, what do you have for us this week for Tricks of the Trade?
Well, I just want to, kind of iterate the point of, be willing to try stuff like this, even if you don't think that it's necessarily something you want to do. I know plenty of developers, they're like, oh, I would never do that because it's so inefficient for joins. I can't do joins efficiently in a document database. It's like, well, you might want to try it and realize that your thinking needs to shift. And so just be willing to do that, because if you're not willing to do that, you're going to have a much harder time. So just bear that in mind. That's one of the things I've been discovering doing this is I probably didn't give the document database idea the credit that it deserved. Even though I did find them very useful, it's like, no, this can really replace a lot more stuff than I thought. So that's about all I've got.
Stand by for Titanfall.
If you have a question or comment, please email us at neckbeards@CompleteDeveloperPodcast.com. Our theme music is an excerpt from Stand By for Titanfall by Pure Bells, available on SoundCloud and licensed through Creative Commons.
The intro music for IoTs is Hillbilly Hip Hop by Jason Belcher. For references, show notes, and to sign up for weekly emails with extra tips and insights, be sure to check out the website at CompleteDeveloperPodcast.com. You can also follow us on Twitter at CompleteDevPod and like our page on Facebook to keep up with news about the show. Catch us each week as we broadcast live, talking about what's going on in the tech world and answering listener questions.
Learn more about all of our shows and groups by going to CompleteDeveloperNetwork.com, where you'll find links to Junior Developer Toolbox, Developer Launchpad, and our other communities. Thanks for listening. See you next time.